Today we revisit this Orchid Righteous 3D that I just recently fixed, or thought I fixed, but a few of your comments triggered me to look at this fix that I put on this card once more. Very briefly, what was the issue? This Voodoo card delivered a bright picture, and it turns out that the VREF voltage that comes out on pin 46 was just too high. Instead of around 1.2, 1.3 volts, it was 1.65. So what I did is I put a resistor across a capacitor here to pull down the voltage to an acceptable level. Today I will also show something that I've been working on for over 6 weeks. And yeah, unfortunately I couldn't show this project yet because it's not yet 100% complete. I'm just waiting for a final revision of a PCB, and I changed the model of an IC. So without verification, I don't want to publish anything yet. But what does it do? Well, let me power on this multimeter and then you will see what I'm talking about. So you see the measurement here in the top left corner. Let's go to ohm reading and let me measure this resistance across this capacitor. And we have 30 kilo ohms. So I can move this away now. And from now on, I have an on-screen display of all the measurements that are coming from my multimeter. How this works? It's coming in the next video. So I hope by then I'll have everything together, and this project will be available to anyone who wants to make their multimeter wireless. But enough about the multimeter now. What do we do about this card? So I put a resistor across this capacitor that pulls down the voltage from the VREF pin. The problem is the VREF is generated inside the RAM duct at the moment, and there is no guarantee that it stays or remains at that level where it is right now. So it could be that over time this value changes, which means this resistor that has a fixed value will no longer pull down to the correct voltage level that it is right now. So we should put a fix in place that remains stable even if the internal fault of this RAM duct is going to change. And we're in luck because the VREF pin allows us to feed it from outside with a reference voltage. So if we can generate 1.23 volts from outside, then we could overcome the fault that is in the RAM duct right now and just supply this chip with the correct reference voltage. One more point I want to address. I got so many comments regarding R set. So this pin is connected to a resistor. In my case, this is absolutely the correct value. I have seen so many Orchid cards and there's always a 147 ohm resistor pulling this pin to ground. Yes, in the documentation for R set pin 42, the resistor here, R3, is supposed to be a 141 ohm resistor, and I have a 147 ohm resistor. But this doesn't seem to be an issue with my other card that I have. It also has a 147 ohm resistor, and I've seen images online. All of them have 147 ohms. So this is definitely not the issue. And if I base my findings on whatever I have researched using Notebook LM, it looks like if the resistance of this 141 resistor is higher, the card should actually deliver a darker picture. And this is not the case for us. So even then, there seems to be an internal fault of the RAM duct. And this is only with the picture brightness. Nothing else in this chip seems to be faulty. That is why I do not want to remove the chip. First of all, I have the sticker on it. I don't want to damage it. I don't want to remove it. I don't want to change the RAM duct. I want to try to salvage this chip and let it be on the card. So my fix that is on the card right now is the poor man's fix, and I want to change this right now, but I will most likely replace it with another poor man's fix because I don't have the proper IC that would generate a proper reference voltage. I decided to go with an AMS1117 adjustable voltage regulator. The minimum voltage this voltage regulator can generate is 1.25 volts, which is very close to our 1.235 volts that the RAM duct requires, but it is still completely within range of this chip. So this is the plan. Let's Frankenstein this linear voltage regulator somehow here in this corner maybe, and not hook it up yet. I want to make sure that we are getting the correct voltage here before I make the connection between this chip and the RAM duct, hopefully overriding then the value that we get on the VREF pin. Now, if you're looking for a proper fix, then you most likely are looking for a precision shunt regulator. I'm not even pretending to understand what this is, but basically it is the same functionality that I'm building with our voltage regulator today. And a model that was suggested was the LM385, but I don't have it. I would have to wait for a long time to get it. And if I can make it work with my current components, then this is good enough for me. And I think many of you would enjoy to get a solution like this hack together and see it working, then going with the LM385 today. Okay, let's go under the microscope and let's get started with the modification of this card. Now, before we continue, I need to get this out as soon as possible because PCBWay celebrates their 12th anniversary, which means lots of discounts and coupons up for grabs, minigames, and of course, premium solder mask colors for the price of standard ones. PCBWay offers their matte black, purple, and pink solder mask colors for the price of standard colors. This is the perfect time to get your PCBs fabricated at PCBWay. Of course, you can also use this opportunity to get one of my projects in the color you were always eyeballing. This is not all. PCBWay offers other services you might require, and there are discounts available as well. CNC machining, 3D printing, sheet metal fabrication, and injection molding, all under one roof. So if you have been holding off to turn your ideas into reality, now is the best time to do it. Head over to PCBWay.com and have a look at their offers and definitely participate in their 12th anniversary celebration. It just takes a few seconds and maybe you will find something you've been waiting for. The details are in the video description, and now let's try to fix this Voodoo card once more. Okay, so I'm planning on keeping this linear voltage regulator here in this corner. Now here's pin 1, this is our adjust pin, this needs to go to ground. The middle one is voltage out, this has to go to our pin, here is my resistor. You might notice that this is a different value that I had before. I was just, trying to optimize it a little bit more. Before it was a 47 kilo ohm, now it's almost a 50 kilo ohm resistor, but that doesn't matter. So the middle pin of our linear voltage regulator is going to connect to our pin 46. And finally, we have our V in. This is a 5 volt supply because the notch is further away from the VGA connectors. So this is a 5 volt card. We are going to use the 5 volt line. Now let me try to figure out where a plus 5 volt is. So here is a tantalum capacitor. Let's see where we can pick up. So here's a 5 volt. Here's 5 volt. Here is 5 volt, that's great. Now we can try to figure out where is ground. So here's one. Ground is here. By the way, I just noticed I maybe need to change the layover to something that's more visible. Let's take this one. So now it should be super easy to see what's going on. So maybe I'll just put this voltage regulator here. We get 5 volts from here as V in. We take ground from here to connect our adjust pin, and we need one resistor to ground to generate the load. This is the one between the output and ground, so we'll place a resistor in here between, but I also want to place a resistor between the output pin and the ramduck pin, because what happens if it shorts out internally? I'm not sure if this is a possibility. And then I dump everything of this linear voltage regulator into pin 46, and that's definitely not good. So I'll put another 200 ohm resistor right here before we go into the ramduck, or maybe even 1 kilo ohm. I think we are pulling down 0.4 volts by using a 50 kilo ohm resistor. A 1 kilo ohm resistor will have enough pull down effect to get rid of the voltage that's generated inside the ramduck. Okay, I think that's my explanation of this hack that we are going to do now. And let's get started. Okay, we are dealing with very limited voltages and current here, so I'll just use these tiny wires to connect. So this is our 5 volt line. Okay, so here's our first connection. Let me double check. So this one here is supposed to be 5 volt in. Yes, and this one is ground. Yes, so I need to connect this to here. So this is our ground pin. Now we have power. We have the adjust pin going to ground. This one I will not connect yet, but we need our load. So our load needs to go to ground. Here is ground. We need to connect our output to ground. So I will get a 200 ohm resistor. I couldn't find a 200 ohm resistor, but I found this 180 ohm resistor. Okay. So this one needs to go between voltage out and ground. And while we are here, we can already put another resistor here. This is the one that then goes to our RAM DAC. It's not gonna be pretty. Okay, I'll clean this up and then let's measure some voltages that we get out of this. So there's no change yet. We'll remove this resistor and hook up our construction here once we verify that we get 1.25 volts out of this regulator. Okay, then let's see what we get on this point when I power on the system. So I already hold my probe to the point that I need to. Let's power on the system. And we get exactly 1.19 volts. I think this is actually very close to what we got on the original card. So we are really good with the voltage. That's actually perfect. So I guess we can hook this up now. Remove our resistor and then see how Tomb Raider looks like. Okay then, let's hook up our voltage regulator to our RAM DAC. First, let's get rid of our patch. Let's see if I can get it off with a soldering iron. Oh yeah, there you go. Yeah, that's perfect. Okay, now we hooked up our Frankenstein mod here that's only held in place by this wire, and then you have all this stuff going on here. I mean, it's honestly, it's an experiment. I would never use this as a proper fix, but what to do with this card? I mean, you can let me know in the comments if you have a better idea. I guess now we are just exploring options, what we can do with a damaged RAM DAC if we don't want to replace it. So I'll clean this up and then we'll test if this works. We'll measure the voltage that we get now on our VREF pin, and then we'll see how Tomb Raider looks like. Hopefully we'll get a perfect color and nothing blows up. Okay, first let's measure what we get on our pin 46 now. And 1.21 volts. Nice. So this should stay like this. So that looks really good. Now let's see if we can run Tomb Raider and hopefully we'll get proper colors. I think this looks good. So now we're injecting voltage from the outside. That looks good actually. I really think this looks perfect. This is how the game should look like. Let's just go quickly into a new game. So yeah, let me know what you think about this way of fixing the RAM DAC. In the first fix, we just used a resistor to draw down the voltage. The problem with this is that if the internal fault of the chip changes, the voltage will drift and we get a different brightness again. Either it can go darker if the voltage goes lower, which I doubt because it went out of spec going up. So I assume that if something is going to happen, it will increase the brightness level again. Now with our 200 ohm resistor that we have there, and yes, we also have a 1 kilo ohm resistor in place right now, but these are actually pulling down the voltage on the entire line to 0. And because we have the linear voltage regulator there, we're going back up and have a stable floor of around 1.2 volts, which is the required voltage for the RAM duct. So now we're injecting the voltage from outside, and it doesn't matter what the fault inside the RAM duct is doing. If it's degraded, that's fine, nothing we can do about it. But if it does change, our solution will still work. The resistor that we had in place before would not. It would continue to change the brightness. It basically would change in relation to the voltage that the RAM duct would generate. Okay, let me know in the comments what you think about this fix. I'm not planning on changing this again to maybe this other IC. I don't know what it was. I think the LM385, if I'm not mistaken. But yeah, so I believe this circuit that we built here does exactly the same thing as this IC. Yeah, you need more components, but it seems to be working. Let me know in the comments what you think. And this is all I have for you today. Thank you so much for watching. Thanks for your time. And of course, thank you to all the people who are supporting this channel. If you want to become a supporter, you can head over to Patreon or become a member here on YouTube. And new, you can also buy me a coffee. Links are in the video description. And finally, I also want to thank PCBWay for sponsoring this video. And next time, we are going to look at this wireless multimeter and how I used an ESP32, a Raspberry Pi 2040, and a few radio modules to get this all to work. This was very interesting, and even it has not much to do with retro computing. Today we have seen what I can do now. I no longer have to point a webcam onto my LCD screen. It is an overlay in OBS. I hope you're excited about this. I think this is one of the most interesting projects that I have worked on so far, but there is going to be another one. And this is something for later this year. But I can tell you, it is fully related to retro hardware. Okay, thank you so much for your time. Thanks for watching, and I will see you in the next video. Take care, and bye-bye.